Hi everyone, welcome to EKM Analytics, where we empower data-driven decisions. My name is Estas Koome. Today, I'll talk about logistic linear regression model in R software. Sit back and enjoy as we learn together. So, what is logistic regression? Logistic regression is a type of regression used when the dependent variable is binary, often coded as 0 and 1. What do I mean by binary? It can either be good or bad, positive or negative, and so on. The factor here is there are two levels. The logistic regression model estimates the probability that y is equals to 1, the event occurs, given the dependent variables x1 all the way to xn. The formula for logistic regression is probability of y is equals to 1 is equals to 1 over 1 plus exponential into power, negative into brackets beta naught plus beta 1 x1 all the way to beta n xn, where p into brackets y is equals to 1 is the probability the dependent variable y equals to 1. Beta naught is the intercept. Beta 1, beta 2, all the way to beta n are the coefficients for the dependent variables. The function 1 over 1 plus exponential into power negative z is the logistic function, also known as the sigmoid function, which transforms the linear combination of inputs into a probability between 0 and 1. For instance, let's assume that you want to fit a logistic regression model to predict whether an individual is diabetic positive or negative with respect to blood glucose level. Here now, a logistic regression model is expressed as probability of diabetes is equals to positive is equals to 1 over into brackets 1 plus exponential into power brackets negative beta naught plus beta 1 star glucose, where diabetes is our dependent variable while glucose is our dependent variable. Logistic regression also has assumptions and conditions that need to be met for the model to be valid. The first condition, binary dependent variable. Of course, the dependent variable must be binary or categorical for multinomial logistic regression. The outcome should be coded as 0 and 1 or other categorical values. Number 2, the linearity of the log of odds. The relationship between the dependent variables and the log of odds, which are logit, of the dependent variable must be linear. This is different from the linearity assumption in linear regression. Number 3, we have independence of observations. The observations should be independent of each other. This assumption implies that each observation in the dataset does not influence the others. Number 4, we have sufficient sample size. Logistic regression requires a large sample size to provide reliable estimates. For binary logistic regression, having at least 10 observations per predictor is recommended. Number 5, no multicollinearity. Independent variables should not be highly correlated with each other. High multicollinearity can distort the estimate of regression coefficients. Unlike linear regression, logistic regression does not rely on residues to access the model fit. Instead, other diagnostic measures and plots are used. The first one, confusion matrix. A confusion matrix shows the counts of actual versus predicted classifications, helping to evaluate the model's accuracy, precision, recall, and other metrics. Number 2, the receiver operating characteristic curve, ROC curve. The ROC curve plots the true positive rate sensitivity against the false positive rate, 1 minus specificity, at different ratio of values. The area under the ROC curve, that is the AUC, provides a measure of the model's ability to discriminate between classes. Number 3, precision recall curve. This plot is particularly used for imbalanced dataset, focusing on the trade-off between precision, positive predicted value, and recall sensitivity. Number 4, pseudo R-squared. Several pseudo R-squared measures, such as the McFadden's R-squared, are used to assess how well the model fits the data. Number 5, log likelihood and deviance. The log likelihood is a measure of how well the model fits the data. Higher values indicate better fit. Deviance is a measure of goodness of fit, and comparing the deviance of different models can help access improvement in model performance. Number 6, VIF, variance inflation factor. VIF is used to check for multicollinearity among the dependent variables. High VIF indicate high multicollinearity, which may need to be addressed. Number 7, Hoffman-Leshmus test. This is a statistical test used to evaluate the goodness of fit for logistic regression models. An insignificant test results suggest that the model fits the data well. That's the end of our part 1. See you in part 2 where I shall be conducting coding in R.